A solitary watcher stands upon a jagged precipice at the very brink of nothingness. Behind them lies the infinite hollow dark of the intergalactic void, a place where the density of matter drops to nearly zero, and the cold is absolute. This is the edge of the great emptiness, the vast gulf that separates the islands of the cosmos. Before this observer, suspended in the velvet gloom, hangs a colossal river of silver and gold. This is the Milky Way, viewed from a distance of hundreds of thousands of light years. It appears as a singular breathing organism of light, a masterpiece of celestial architecture that suggests a profound and unshakable order. From this remote vantage point, the galaxy is a silent clockwork mechanism, a rotating disk of 200 billion suns, each one a tiny spark contributing to a grand, harmonious glow. It looks like a sanctuary of permanence, a place where the laws of the universe are written in stone and obeyed with mathematical precision. The light travelling from this distant spiral has journeyed for eons to reach the observer's eyes, carrying with it the illusion of peace. The spiral arms, vast and elegant, curve with the grace of a nautilus shell, suggesting a fluid motion that has remained unchanged for billions of years. In this wide-angle view, the physics of the galaxy seems simple, governed by the elegant equations of gravity and motion that humanity has spent centuries perfecting. There is no hint of the turmoil within. The observer sees a majestic, rotating jewellery box, where every star and every nebula sits in its rightful place, bound by the invisible threads of a predictable universe. It is a vision of cosmic perfection that invites a sense of belonging and safety. The silver glow of the galactic bulge, the soft dusting of the spiral arms, and the dark lanes of interstellar dust all speak of a system in perfect equilibrium. But as the perspective shifts, plunging through the thin veil of the galactic halo and into the dense thicket of the disk, the veneer of stability begins to crack and peel away. The silence of the distance is replaced by a metaphorical roar of energy. The closer one gets to the heart of this luminous spiral, the more the facade of harmony dissolves. The stars are no longer fixed points in a peaceful tapestry. They are burning furnaces of nuclear fire, hurtling through the dark at speeds that defy easy calculation. The space between them is not empty, but filled with the violent remnants of dead suns and the turbulent gas of stars yet to be born. The clockwork is broken. The gears are grinding against one another, and the very fabric of reality is being stretched to its absolute breaking point. We are not living in a tranquil island of light. Instead, we inhabit a cosmic crime scene, a place where the fundamental laws of nature are being interrogated and found wanting. As the gaze penetrates deeper into the galactic centre, the familiar rules of physics start to warp. Light does not merely travel, it screams into the void, bent and distorted by masses that should not exist. Space does not merely contain the stars, it tears asunder, ripped by gravitational forces so intense that they mock the very concept of a stable universe. This is a realm where the equations written by the greatest minds of our species are stretched until they snap. The Milky Way is a place of beautiful, terrifying lawlessness, where the matter we can see is a mere dusting of snow on a dark and heavy mountain of the unknown. Our home is actively defying every equation we have ever written to describe it. The stars at the outer edges of the galaxy move with a defiance that suggests an invisible hand is holding them in place, a hand that neither emits nor reflects light. This dark scaffolding, which outweighs the visible stars by a factor of nearly 10 to 1, remains one of the greatest embarrassments of modern science. The centre of the galaxy is not a point of rest, but a howling abyss that swallows time itself, a gravitational titan that dictates the movements of everything within its reach. We have spent centuries trying to map this structure, trying to fit it into the boxes of our understanding, only to find that the more we see, the less we truly comprehend. The Milky Way is a paradox, a structure of impossible scale and energy that functions despite the fact that our best theories say it should have flown apart long ago. The very history of this place is written in the language of collision and consumption. The galaxy we see today is a scarred survivor of ancient wars, having devoured smaller galaxies and absorbed their stars into its own body. These celestial ghosts still haunt the disk, moving in patterns that contradict the expected flow of galactic matter. The disk itself is not flat but warped and vibrating, responding to the gravitational echoes of past traumas. Every measurement we take reveals a new inconsistency, a new way in which the Milky Way refuses to behave like the elegant clockwork we once imagined. It is a dynamic, evolving, and often violent entity that cares nothing for our desire for order. This is the story of that defiance. It is a journey into the heart of a mystery that spans 13.8 billion years. We are the children of this chaos, born from the debris of a violent history that we are only now beginning to reconstruct. Every atom in our bodies was forged in the hearts of stars that were tossed around this galactic disk like grains of sand in a storm. To understand the Milky Way is to understand that we are living on the edge of a precipice, looking into a void that is far more active, far more dangerous, and far more wondrous than we ever dared to believe. The silver river of light is a mask, and behind that mask lies a reality that challenges everything we think we know about the nature of existence. We find ourselves standing at the threshold of a new era of discovery, where our old maps are being burned and replaced by a reality that is far more complex than we ever anticipated. The laws of gravity, the nature of matter, and the very flow of time are all under assault by the data streaming in from our most advanced instruments. We are forced to confront the fact that our home is not a finished masterpiece, but a work in progress, a turbulent and unpredictable system that continues to surprise us. This silent architect of chaos has left its fingerprints everywhere, from the fastest moving stars at the galactic rim to the gargantuan bubbles of energy rising from the core. As we begin this investigation, we must leave behind the comfort of the familiar and prepare to see the Milky Way for what it truly is. A magnificent, broken, and utterly defiant wonder of the cosmos. The quest to chart this labyrinth began not with sophisticated sensors, but with the patient, flickering candlelight of the 18th century. William Herschel, a man obsessed with the architecture of the heavens, stood before his towering telescopes of polished metal and wood, attempting to do the impossible. He sought to measure the boundaries of the entire universe by the simple act of counting stars. To Herschel, the Milky Way was a finite cloud of suns, and he believed that by peering into the darkness and recording every spark of light in 683 distinct directions, he could divine the shape of the whole. He laboured under the elegant but flawed assumption that the stars were distributed evenly through space, like grains of salt scattered across a table. In his mind, the further he could see, the more stars he would count, and where the counting stopped, the edge of the world began. He was a blind man attempting to describe the contours of a mountain while standing in a thick fog, unaware that the very air around him was choked with the soot of the cosmos. Herschel could not see the vast, dark curtains of interstellar dust that blocked his view, masking the true extent of the galaxy. He concluded that we lived near the centre of a small, flattened disk of stars, a modest island of light in an otherwise empty sea. This model was a masterpiece of simplicity, a neat and tidy answer to a question of infinite complexity. It placed humanity at the heart of the cosmic story, reinforcing the ancient belief that the heavens were a structured, orderly reflection of a divine plan. But the universe had no intention of following the lines drawn by a man with a telescope in a garden in England. As the 19th century gave way to the 20th, the tools of the cartographers grew more powerful, and the cracks in Herschel's small, centered universe began to widen. The stage was set for a confrontation that would shatter the human ego and expand the boundaries of reality itself. In the year 1920, within the walls of the Smithsonian Museum of Natural History, two giants of astronomy, Harlow Shapley and Heber Curtis, engaged in what would become known as the Great Debate. They were not merely arguing over distances, they were wrestling for the soul of the galaxy. Shapley had looked beyond the local stars, focusing his attention on the globular clusters, tight, ancient swarms of hundreds of thousands of suns that hover like moths around the galactic core. By measuring the distances to these clusters using the pulsing light of variable stars, he realized that they were not centered on the sun. Instead, They were gathered around a distant invisible point in the constellation of Sagittarius. This discovery was a hammer blow to the old order. Shapley argued that the Milky Way was far larger than anyone had dared to dream, a sprawling disk spanning 300,000 light-years. More importantly, he claimed that the Sun was not the centre of this structure, but was instead tucked away in a nondescript corner, a lonely outpost in the galactic suburbs. While Shapley was correct about our position, he believed the Milky Way was the entire universe, a singular, all-encompassing continent of stars. Heber Curtis, however, looked at the faint spiral nebulae that dotted the deep sky and saw something else entirely. He proposed that these were not small clouds of gas within our own galaxy, but were island universes in their own right, galaxies as large and complex as our own, situated at distances so vast they defied human comprehension. The resolution of this debate did not bring the expected peace of a settled equation. Instead, it revealed a reality that was messy, violent, and far larger than the human mind was evolved to process. We learned that we inhabit a galaxy that is roughly 100,000 light-years across, containing hundreds of billions of suns, and that our own star is merely one of many, orbiting a distant centre at a speed of 500,000 miles per hour. The elegant simplicity of the early models was replaced by a sprawling, chaotic structure, filled with hidden dangers and invisible forces. The discovery of our true place in the galaxy was our first real hint that the universe was not a static backdrop, but a dynamic and often terrifying machine. This shift in perspective was more than a change in coordinates. It was a fundamental reorganization of how we perceive the laws of physics. We realized that the light we see is only a fraction of what exists. The early cartographers were looking at the foam on the surface of a deep and turbulent ocean, unaware of the currents moving in the depths below. They built their maps on the light of suns, but the galaxy was being shaped by shadows. The realization that we are a small part of a much larger and more complex structure forced us to ask if the rules we observed in our local neighbourhood applied to the rest of the cosmos. We began to suspect that the stability we observed was an illusion, a temporary lull in a much longer and more violent story. The maps of the 20th century revealed a Milky Way that was alive with motion. We saw spiral arms that were not solid structures, but waves of pressure moving through gas and dust, triggering the birth of new stars. We saw the remnants of dead suns casting their guts into the void, enriching the galaxy with the heavy elements necessary for life. But even as these maps became more detailed, they also became more haunting. The more we measured the movements of the stars, the more we realized that the numbers did not add up. The galaxy was moving in ways that the visible matter could not explain. The foundation of elegant simplicity had finally crumbled, leaving us to stand on the edge of a much darker and more mysterious frontier. The maps were no longer just about where the stars were. They were about why they stayed together at all, and what invisible ghosts were pulling the strings from the shadows. The first major fracture in the crystalline logic of galactic physics did not manifest in the blinding glare of the core, but in the lonely, cold reaches of the outer rim. In the decade of the 1970s, the astronomer Vera Rubin turned her gaze toward the distant spinning disks of spiral galaxies, seeking to confirm the fundamental laws that governed the motion of all things. She employed a spectrograph to catch the light of stars at the very fringes of these cosmic structures, breaking their glow into a rainbow of data that could reveal their hidden velocities. According to the long-standing laws of Newtonian gravity and the orbital mechanics defined by Johannes Kepler, the result should have been a foregone conclusion. The further a star is from the concentrated mass of the galactic centre, the weaker the tether of gravity becomes. Just as the outer planets of our solar system crawl through their orbits while the inner worlds race, the stars at the galactic rim should have been drifting like loose petals caught in the waning energy of a dying storm. But the light told a different, more disturbing story that shattered the expectations of the scientific community. As Rubin measured the speeds of these distant suns, she found that they were not slowing down at all. Instead, they were hurtling through the dark at the same frantic pace as the stars much closer to the heart of the galaxy. The rotation curves she plotted were flat, a straight, defiant line that slashed through the heart of established physics. The stars at the edge were moving with such terrifying momentum that they should have been flung into the intergalactic void, escaping the galaxy's reach forever. By all the rules of known science, the visible matter of the Milky Way, the combined mass of its hundreds of billions of suns, its glowing nebulum, and its vast clouds of gas, was not nearly heavy enough to hold the machine together. The galaxy was acting like a celestial carousel where the horses on the outer edge were moving far too fast for the strength of the wood, and iron holding them to the centre. If one were to calculate the centrifugal force generated by these racing stars, the result was clear. The Milky Way should have shredded itself eons ago. Its spiral arms should have unspooled, scattering its stellar inhabitants across the emptiness of space like sparks from a grinding wheel. Yet, the stars remained. They clung to the centre with an invisible iron grip, held by a tether that the eyes could not see, and no instrument could directly detect. This was not a mere anomaly. It was a fundamental crisis of reality. The equations that had successfully landed humans on the moon and predicted the paths of comets were failing to explain the very structure of our home. To save the mathematics of the universe, a new ghost was summoned from the mathematical shadows: dark matter. This was not described as a simple substance, a mere collection of cold gas or hidden planets, but as a spectral scaffolding that permeates and surrounds every galaxy. It is an invisible ocean of mass that provides the extra gravitational anchor needed to keep the stars from flying away. Dark matter mocks the standard model of physics with its total refusal to interact with the electromagnetic spectrum. It does not reflect light, it does not absorb it, and it does not emit it. It passes through solid walls and through the very bodies of observers like a phantom, felt only through the heavy, silent pull of its gravity. It suggests that everything we have ever seen, every burning star, every planet, every swirl of luminous dust, is nothing more than a thin layer of bioluminescent algae floating on the surface of a deep, dark, and heavy sea. This spectral scaffolding accounts for more than 80% of the matter in the universe, yet it remains fundamentally alien to us. Its presence forces a confrontation with a chilling possibility that our understanding of gravity is not merely incomplete, but fundamentally broken. Some theorists began to wonder if the laws of motion change once the distances become vast enough, suggesting that gravity might behave differently across the span of 100,000 light-years than it does within the confines of a single solar system. This tension between the visible and the invisible created a new kind of scientific dread. We are left to question if the very ground of our reality is built on a substance we can never touch, or if the logic we use to navigate the world is an illusion that dissolves when applied to the scale of the cosmos. The rotation paradox turned the Milky Way into a haunted house of physics. We began to visualize the galaxy not as a collection of stars, but as a vast, dark sphere of unknown material, within which the visible galaxy is a tiny, glowing inhabitant. This dark halo is the true master of the galaxy's fate, dictating the speed of every star and the shape of every spiral arm. The visible light we spent centuries mapping is merely a passenger on a much larger, darker vessel. The iron grip of this invisible mass ensures that the galaxy remains a coherent unit, but it does so by defying the very rules that humanity once thought were universal. We are forced to admit that we are surrounded by a vast ocean of matter that refuses to touch the light, a silent architect that holds our world together while remaining forever out of reach. As we look at the stars racing at the galactic rim, we are watching a performance that should be impossible. Each sun is a witness to a hidden truth, its velocity a scream into the void that something massive is lurking in the dark. The discovery of this rotation paradox was the moment the Milky Way ceased to be a predictable clockwork and became a site of profound scientific mystery. It revealed that the universe is not made of the things we can see, but is instead governed by a ghost in the machine, a force that provides the scaffolding for all of existence while mocking our attempts to define it. We are living inside a structure that is held together by a secret, and the more we study the motion of the stars, the more that secret threatens to unravel our entire understanding of the physical world. This invisible ocean of matter does not merely exist alongside the stars, it defines the very arena in which they play. Beyond the glowing edges of the galactic disk lies a colossal spherical shroud known as the dark matter halo, an entity that dwarfs the visible Milky Way in both scale and influence. If the spiralling arms of our galaxy are a delicate embroidery of light, this halo is the heavy, coarse canvas upon which it is stitched. It extends hundreds of thousands of light years into the surrounding gloom, a silent pressure that dictates the rhythm of every orbit. We move through this medium every second of our lives, yet it offers no resistance, no friction, and no warmth. It is a ghost in the machine of the cosmos, a substance that fundamentally rejects our every method of detection. For decades we have built crystalline detectors deep within the Earth, shielding them from the rain of cosmic rays in hopes of catching a single subtle vibration, a stray collision between a particle of this dark mass and the matter we understand. But the detectors remain silent. The universe refuses to speak. The tension between the matter we can see and the gravitational influence we can measure has become a profound source of scientific dread. When we sum the masses of every sun, every planet, every asteroid, and every wisp of hydrogen gas, we arrive at a figure that represents a mere 10% of what is required to explain the galaxy's behaviour. 90% of our home is missing. We are the minority, a tiny fraction of baryonic matter, the 5% of the total universe that has the audacity to glow, clinging to a structure built by something we do not comprehend. This realization carries a heavy weight of isolation. We are like shipwrecked sailors on a raft, marveling at the wood beneath our feet while ignoring the miles of lightless water that support us. The visible galaxy is nothing more than the bioluminescent foam on the crest of a dark, deep wave, an accidental byproduct of a much larger and more somber process. This missing mass is not merely a mathematical placeholder, it is a physical presence that mocks the limits of human perception. Every star in the sky is a prisoner to this unseen master. We watch as distant galaxies collide and merge, their dark halos intermingling long before their stars ever meet, and we see the gravitational lensing, the warping of space itself, that reveals the presence of this invisible weight. It bends the light of distant quasars like a thick, distorted lens, creating multiple images of a single object, yet when we turn our telescopes to the source of this bending, we see nothing. The void is heavy. The emptiness is full. This rejection of the electromagnetic spectrum, the refusal to interact with the very force that allows us to see, feel, and touch the world, suggests that we are surrounded by a substance that is fundamentally other. It does not participate in the dance of chemistry. It does not form atoms or molecules or life. It simply pulls. The dread lies in the possibility that we are trying to solve a puzzle with pieces that do not fit. If this 90% of the galaxy is truly made of particles that do not feel the touch of light, then we are effectively blind to the majority of reality. We have spent centuries perfecting the art of seeing, only to find that the most important things in the universe are invisible. This creates a sense of profound cosmic loneliness. We are built of the rare, the noisy, and the bright. While the rest of the cosmos is silent and dark, we are the anomaly. The standard model of physics, which has served us so well in the laboratory and the workshop, feels increasingly like a lighthouse that illuminates only a few feet of a vast and stormy coast. Beyond the reach of its beam, the dark matter halo looms, an ancient and indifferent architect that was present at the birth of the first stars and will remain long after the last one has flickered out. This ocean of the unknown forces us to question the very nature of our senses. We are tuned to a frequency that the rest of the universe largely ignores. While we obsess over the movements of the planets and the life cycles of the suns, the dark matter is the true driver of galactic evolution. It was the gravitational seeds of this dark mass that first drew the primordial gas together after the beginning of time, allowing the first galaxies to coalesce. Without this invisible scaffolding, the gas would have remained scattered, too thin and too hot to ever collapse into the fires of a star. We owe our very existence to a ghost that refuses to acknowledge us. We are the guests in a house built by a shadow, and we are only now beginning to realize that the walls are much thicker and colder than we ever imagined. As we look out from our small blue world, we must reckon with the fact that we are moving through a sea of matter that could at any moment pass through our bodies without a trace. It is here in the room with us, it is passing through the heart of our sun, it is filling the spaces between our thoughts, yet it remains as distant as the furthest quasar. The isolation is absolute. We are separated from the majority of our own galaxy by a barrier of fundamental physics that we may never breach. This missing 90% is a constant reminder of our limitations, a silent sentinel that watches over the Milky Way, ensuring its integrity while remaining forever outside our grasp. We are the light dwellers, the accidental witnesses to a dark and heavy masterpiece that was never intended for our eyes. The ghost in the machine is not an intruder. It is the machine itself, and we are merely the sparks flying off the gears. The journey inward from the dark, quiet suburbs of the galaxy leads to a place of suffocating density. As one approaches the core, the distance between stars shrinks from light years to light weeks, then light days. The sky here is not a black velvet curtain, but a blinding, continuous wall of fire, where the combined radiation of millions of suns washes over every planet in a relentless deluge of heat and X-rays. Yet, at the very geometric centre of this frantic swarm, there is a hole in the universe. This is Sagittarius A star, the supermassive black hole that serves as the dark heart of the Milky Way. It is a point where the geometry of space-time is so severely curved that it folds in on itself, creating a trap from which not even light can escape. It is a 4 million-fold concentration of the mass of our Sun, compressed into a region of space smaller than the orbit of Mercury. For decades, astronomers watched a group of elite stars known as the S-stars as they performed a high-stakes ballet around this invisible titan. These suns do not drift. They scream through the void at relativistic speeds, reaching several % of the speed of light as they make their closest approach to the abyss. One star in particular, designated as S2, has been tracked through its entire 16-year orbit, providing the most rigorous test of gravity ever conducted. As it swings around the black hole, the gravity is so intense that the star's light is stretched toward the red end of the spectrum, a phenomenon known as gravitational redshift. Time itself slows down in the vicinity of the void, ticking at a different rate than it does for the observers on Earth. This frantic dance is a triumphant confirmation of the predictions made by Albert Einstein over a century ago. His equations of general relativity, which describe gravity as the curvature of space-time, have held firm against the most extreme conditions the galaxy can offer. Yet, even as Einstein is vindicated, the dark heart of the galaxy points toward the threshold where his legacy must end. At the very centre of the black hole lies the singularity, a point of infinite density and zero volume where the mathematics of the smooth, continuous fabric of space-time collide with the jagged, probabilistic world of quantum mechanics. Here, the equations fail. They produce infinities that signify a breakdown in our understanding of reality. The black hole is a gatekeeper, standing at the edge of the known and the unknowable, guarding secrets that the current laws of physics are forbidden to reveal. It is a place where the concept of now loses its meaning, and the distinction between space and time dissolves into a singular, terrifying entity. Sagittarius. A star is not merely a consumer of matter, a cosmic vacuum cleaner lurking in the shadows. It is the silent, heavy anchor around which the entire galactic narrative is spun. Though its mass is but a tiny fraction of the total galaxy, its presence is the gravitational north pole for every star in the Milky Way. It is the architect of the core, its tidal forces shredding encroaching gas clouds and occasionally devouring a wandering star, an event that sends flares of high-energy radiation echoing through the spiral arms. This dark heart regulates the growth of the galaxy, its feedback loops of energy preventing the core from collapsing into a single, monstrous star. It is a paradox of creation and destruction, a void that provides the stability necessary for the surrounding millions of stars to exist in their crowded, luminous neighbourhood. To look upon the centre is to see the ultimate expression of the galaxy's broken physics. It is a region where the invisible dark matter, the visible stars, and the crushing gravity of the black hole all converge in a violent struggle for dominance. The S-stars, in their relentless high-speed orbits, are the messengers of this struggle. They carry the news that the universe is far more extreme than our earthly intuition suggests. They show us that gravity is not just a force that keeps our feet on the ground, but a power that can warp the very dimensions of existence. The dark heart of the Milky Way remains a silent sentinel, a master of the celestial carousel that keeps the horses moving at their impossible speeds, ensuring that the story of the galaxy continues to unfold around its heavy, unmoving centre. This anchor is the final word in the galactic hierarchy. Every star, from the smallest red dwarf to the most massive blue giant, owes its orbital path to the presence of this central void. It is the ultimate manifestation of the crime scene we inhabit, a place where the evidence of a deeper, more fundamental law of nature is hidden behind an event horizon that we can never cross. We are left to watch the dance from afar, measuring the light of the S-stars and calculating the curvature of the dark, knowing that the most important answers lie in a place where we can never go, governed by a physics we have yet to invent. The black hole's influence extends far beyond the immediate vicinity of its event horizon. It is the engine of a much larger and more mysterious metabolism, one that breathes fire into the heights of the galactic halo. As we move away from the crushing gravity of the core, we begin to see the evidence of the black hole's past outbursts, gargantuan structures that dwarf the very disk of the galaxy itself. The heart is not just a passive consumer, it is a source of violent energy that has periodically erupted throughout cosmic time, leaving behind ghosts that haunt the space above and below the galactic plane. The evidence of this volatility is etched into the very sky, though it remains hidden from the limited range of human vision. Rising like two gargantuan shimmering lungs from the centre of the galaxy are the Fermi bubbles, colossal structures of high-energy gamma rays that tower 25,000 light-years above and 25,000 light-years below the galactic plane. To an eye capable of seeing in the highest frequencies of light, these would appear as two iridescent orbs, each half the size of the entire visible Milky Way, glowing with a ghostly violet intensity. These are not clouds of gas or dust, but the spectral remains of a titanic eruption, the ghosts of a past explosion that occurred millions of years ago. They suggest that the metabolism of our galaxy is far more erratic and violent than the steady, rhythmic ticking of a clock. The discovery of these structures by the Fermi Gamma Ray Space Telescope shattered the long-held image of a dormant and peaceful galactic centre. For generations, we believed that Sagittarius A star was a sleeping giant, a quiet consumer that only occasionally nibbled on a stray cloud of hydrogen. The bubbles tell a different story, a story of a dragon that once exhaled a breath of fire so immense that it carved its signature into the very vacuum of space. This was a singular event of staggering proportions, a moment when the dark heart of the galaxy became a fountain of pure energy. Whether this was caused by the sudden, simultaneous collapse of thousands of massive stars or by the supermassive black hole devouring a truly monumental feast of gas, the result was a geyser of plasma moving at millions of miles per hour. This jet of matter and radiation punched through the dense gas of the galactic disk and screamed into the halo, inflating these two enormous cavities with high-energy particles. These structures defy current energetic models. The sheer amount of energy required to inflate such gargantuan volumes against the pressure of the surrounding galactic medium is almost beyond calculation. It represents a release of power equivalent to tens of thousands of supernovae detonating at once. This realization forces a re-evaluation of the Milky Way's history. Our home is not a static structure that reached its final form billions of years ago. It is an active, breathing engine with a history of catastrophic outbursts. The Fermi bubbles are a warning that the tranquility we observe today is merely a temporary lull in a much longer and more turbulent cycle. We are living in the aftermath of a cosmic tantrum, a period of relative calm that follows a storm of unimaginable proportions. The presence of these gamma-ray ghosts reveals a hidden architecture of energy that surrounds us. We are not merely inhabitants of a flat disk. We are encased in a massive, multi-layered cocoon of radiation and magnetic fields. The bubbles act as a testament to the fact that the centre of the galaxy is a place of extreme physics, where the rules of the mundane world are discarded. In this high-energy realm, particles are accelerated to nearly the speed of light, and the vacuum of space itself becomes a medium for the transport of immense heat. This is the metabolism of a predator, a system capable of storing and then suddenly releasing energy on a scale that can influence the evolution of the entire galaxy. The bubbles may even play a role in regulating the birth of new stars, their heat preventing gas from cooling and collapsing into new suns, thereby acting as a cosmic thermostat. To study the Fermi bubbles is to confront the reality that our galaxy has a memory. These structures have persisted for millions of years, a lingering echo of a moment when the laws of thermodynamics were pushed to their limit. They contradict the visual evidence of our telescopes, which show a core that appears relatively dark and quiet. They remind us that the light we see is often a deceptive mask hiding the true nature of the forces at play. The dragon in the basement may be sleeping now, but the heat of its last breath still lingers in the heights of the halo, a reminder that the heart of the Milky Way is a source of violent energy that can, at any moment, rewrite the fate of the stars. This volatile history connects the supermassive black hole to the furthest reaches of the galactic outskirts. It shows that the influence of the core is not limited to the stars in its immediate orbit, but extends tens of thousands of light years into the void. The bubbles are a bridge between the microscopic scale of the black hole's event horizon and the macroscopic scale of the entire galactic ecosystem. They prove that the Milky Way is a singular, interconnected organism, where a disturbance at the centre can send ripples through the entire structure. As we look up into the night sky, we must understand that we are standing beneath the shadow of these invisible giants, the silent witnesses to a past that was far more incandescent than our ancestors ever dreamed. The galaxy is a site of ongoing, high-energy drama, and we are merely living in a brief interval between the acts of a much larger and more terrifying performance. This realization of a restless, energetic home prepares us for an even more startling discovery. The very ground beneath our feet, the galactic disk itself, is a scarred landscape of ancient and ongoing collisions. The arrival of the Gaia spacecraft at its lonely outpost, nearly 1 million miles from the surface of the Earth, signaled the beginning of a profound transformation in our understanding of the cosmic neighborhood. This sentinel of glass and silicon, perched at the second Lagrange point where the gravities of the Sun and our world find a delicate balance, began a mission of unprecedented ambition. It did not merely take photographs. It performed a census of more than 1 billion stars, measuring their positions, their distances, and their velocities with a precision that was previously thought impossible. Gaia turned the Milky Way from a blurry, two-dimensional snapshot into a high-definition, six-dimensional reconstruction of reality. As the data poured back to the waiting minds on Earth, the image of our home as a pristine, elegant disk of light was shattered forever. In its place emerged the portrait of a scarred survivor, a structure defined not by its harmony, but by its history of brutal and ancient encounters. The map revealed by Gaia shows that the galactic disk is not a flat, stable plane, but a warped and buckled landscape. The edges of the Milky Way flare upward on one side and downward on the other, twisted like a vinyl record left too long in the heat of the sun. This warp is not a static feature. It is a dynamic, rotating wave that ripples through the outer reaches of the galaxy. It is the result of unseen forces, the gravitational ghost of satellite galaxies that have tugged and pulled at our disk for eons. The very ground upon which our sun orbits is in a state of constant slow-motion upheaval, responding to the presence of smaller neighbours that orbit the Milky Way like angry wasps. This discovery proved that the galaxy is not a closed system in a state of perfect equilibrium, but an open, reactive entity that is still reeling from the influence of its surroundings. The most startling revelation from the Gaia data was the discovery of a subtle, intricate pattern in the movement of the stars near our Sun. When the velocities of these stars were plotted against their positions, they revealed a beautiful, haunting shape, a phase spiral. This is the signature of a galaxy that has been struck, a cosmic bell that is still ringing from a massive impact. Hundreds of millions of years ago, a smaller galaxy, likely the Sagittarius dwarf, punched through the disk of the Milky Way, sending a shockwave through the stellar population. The stars were knocked out of their comfortable circular orbits and forced into a collective, spiralling dance as they struggled to find a new balance. We are living in the middle of that resonance. The vibration is still moving through us, a lingering echo of a collision that occurred long before the first ancestors of humanity walked the Earth. This ringing reveals that the Milky Way is in a state of constant non-equilibrium. It is a system that has never truly settled down, a structure that is perpetually recovering from the trauma of its past. The very shape of our home, its thickness, its warps, and the arrangement of its stars is a fossil record of violence. We see the scars of ancient mergers and the ripples of recent flybys, all etched into the positions of the suns we see in the night sky. The elegance of the spiral arms is a mask for a much messier reality. They are waves of density moving through a medium that is already turbulent and broken. The galaxy is a scarred landscape, and every star is a witness to a history of celestial combat. The realization that the Milky Way is a product of trauma changes the way we view the physics of galactic evolution. We can no longer think of the galaxy as a self-contained island that grew in isolation. It is a predator and a victim, a participant in a grand, multi-billion-year struggle for mass and dominance. The pristine models of the past were based on the assumption that the galaxy had reached a final, stable state, but Gaia has shown us that stability is an illusion. The disk is a living, vibrating thing, responding to the gravitational tides of the local group. It is a structure that is being constantly reshaped by the very forces that seek to tear it apart. This new perspective forces us to confront the fact that our own sun's path through the galaxy has been dictated by these ancient collisions. We are passengers on a vibrating platform, moving through a disk that is buckled and bruised. The stability of our solar system exists within a larger context of galactic instability. The very air we breathe and the heavy elements that make up our world are the products of a cycle of birth and death that was triggered in part by the turbulence of these mergers. The trauma of the Milky Way is the reason we are here. The collisions that scarred the disk also compressed clouds of gas and dust, sparking the formation of new generations of stars, including our own. As we look at the high-definition map provided by Gaia, we see a galaxy that is far more complex and far more interesting than the one we imagined. It is a structure with a memory, a place where the past is never truly gone but is instead preserved in the motions of the stars. The silent architect of chaos has left its mark on every corner of the disk, ensuring that the Milky Way remains a site of ongoing physical drama. We are just beginning to reconstruct the story of these ancient encounters, piecing together the evidence of a violent history that has made our galaxy what it is today. The most significant of these scars, a massive signature of a devoured world, lies hidden in the very heart of the stellar population, a ghost that we have only recently learned to name. 10 billion years ago, the primordial Milky Way was a much smaller, more frantic structure, a gathering of gas and ancient stars that had yet to settle into the grand spiral we recognize today. Into this burgeoning system fell a Titan, a satellite galaxy of immense proportions that modern astronomers have posthumously named Gaia Enceladus. This was not a gentle merging of two equals, but a catastrophic head-on collision that forever altered the trajectory of our home. The Milky Way, acting as a relentless galactic cannibal, tore the intruder apart, stripping away its gas and scattering its stars like seeds across the celestial landscape. This event was so profound that it effectively inflated the galactic disk, creating a second, puffier layer of stars known as the thick disk. The remains of this consumed world are not gone. They are still here, hiding in plain sight, vibrating through the very neighbourhood where our sun now resides. Like a forensic investigator walking a stretch of highway littered with shattered glass and twisted metal, scientists have used the data from the Gaia mission to reconstruct this ancient disaster from the debris scattered across the galaxy. By looking at the velocities and the chemical compositions of thousands of stars, they have identified a population of stellar inhabitants that simply do not belong. These stars move on elongated, needle-like orbits that plunge toward the galactic centre and then swing back out to the furthest reaches of the halo, tracing a shape in velocity space that resembles a distended sausage. This peculiar motion is the signature of their violent entry into our system. They are the survivors of a conquered world, still carrying the kinetic energy of their original home as they drift through the modern Milky Way. The identification of these stars relies on more than just their speed. It depends on the genetic markers etched into their very light. Stars born within the main body of the Milky Way carry a specific chemical signature, a ratio of heavy elements like iron to lighter elements like magnesium that reflects the unique history of our galaxy's star formation. The stars of Gaia Enceladus, however, are foreigners. They are poorer in heavy metals, revealing that they were forged in a smaller, less evolved environment before being hijacked by the Milky Way's superior gravity. This chemical mapping allows us to see the galaxy as a graveyard of devoured civilizations. We can trace the lineage of these stars back 10 billion years, identifying which ones were born here and which ones were stolen during the Milky Way's long history of predatory growth. This systematic absorption of neighbours is the primary mechanism by which our galaxy has grown into the behemoth it is today. The Milky Way is not a singular, unified entity, but a composite of many different worlds, a mosaic of galactic fragments stitched together by the uncompromising force of gravity. We are living inside a structure that has been built through a series of hostile takeovers. Every time the Milky Way devours a smaller galaxy, it adds to its mass, its complexity, and its internal turbulence. The Gaia Enceladus event was merely the largest of these meals, a feast that provided the raw materials for the next generation of stars and helped stabilize the disk into its current form. But the scars of this meal have never truly healed. The sausage stars continue to move in their eccentric patterns, refusing to settle into the circular orderly orbits of the native population. This realization reframes the Milky Way as a competitive and violent actor in the local group. It is a predator that has spent billions of years clearing its immediate surroundings of any potential rivals. We see the evidence of this cannibalism not just in the deep past, but in the ongoing destruction of smaller satellite galaxies like the Sagittarius dwarf, which is currently being shredded by the Milky Way's tidal forces. The galaxy is a site of perpetual conflict, where the strong survive by consuming the weak. The stars we see in the night sky are the participants and the victims of this struggle, their positions and movements dictated by a history of orbital mechanics that cares nothing for the preservation of individual worlds. The forensic reconstruction of the Gaia-Enceladus collision teaches us that the history of our galaxy is written in the language of motion. Every star is a data point, a fossilized moment of a past encounter. By studying these sausage stars, we are able to look back to a time when the universe was younger, denser, and far more crowded. We see a period of intense activity where galaxies were constantly jostling for position, colliding and merging in a frantic race for mass. The Milky Way emerged from this era as a victor, a massive and dominant structure that had successfully integrated the remains of its fallen enemies into its own body. But there is a haunting quality to this victory. The stars of the devoured galaxy are still among us, moving like ghosts through the disk. They are a constant reminder that the stability of our current era is a fragile thing, built upon a foundation of ancient destruction. The very atoms that make up our world may have once been part of a completely different galaxy, brought here by the gravitational winds of a 10-billion-year-old storm. We are the products of this cannibalism, the beneficiaries of a violent and competitive past that has left the Milky Way in a state of constant, subtle vibration. As we peer deeper into the movements of these stellar streams, we realize that the galaxy is not just a graveyard, but a complex web of overlapping histories, where long ribbons of stars move through the dark, refusing to conform to the patterns we once thought were universal. Within this vast, rotating graveyard, there exist structures that defy the very logic of a liquid or gaseous universe. These are the stellar streams, ethereal ribbons of stars that stretch across the sky like the fraying threads of a celestial tapestry. They are the remnants of ancient globular clusters and dwarf galaxies that ventured too close to the gravitational maw of the Milky Way and were systematically unspooled. As these smaller bodies were captured, the tidal forces of our galaxy acted like a relentless rack, pulling at the leading and trailing edges of the clusters until they were stretched into long, thin filaments. Thousands of stars, once bound together in a tight spherical knot, are now distributed along an orbital path that can span hundreds of thousands of light-years. They move through the galactic disk like ghosts, occupying the same physical space as the native stars but remaining fundamentally apart, tracing the invisible lines of a history that refuses to be forgotten. The paradox of these streams lies in their incredible longevity and their refusal to dissolve. According to the classical laws of fluid dynamics and the expected behavior of a many-body system, these thin ribbons should have been dispersed eons ago. In a galaxy as turbulent and crowded as our own, the constant gravitational tugging of passing gas clouds, the influence of the spiral arms, and the sheer chaotic motion of billions of suns should act like a blender, mixing these streams into the background population until no trace of their origin remains. Yet they persist. They drift through the galactic storm like delicate silk threads, seemingly untouched by the surrounding chaos. They maintain their coherence and their distinct velocities, moving on tracks that cut across the grain of the rest of the galaxy. To look upon a stellar stream is to witness a structure that is in the Milky Way, but not of it. This persistence reveals that the Milky Way is far from a settled or mixed system. It is not a well-blended soup where the ingredients have lost their individual identities, but a complex web of overlapping histories that we are only beginning to disentangle. Each stream is a distinct chapter of the galaxy's past, a fossilized record of a specific encounter that occurred millions or even billions of years ago. We are living in a palimpsest, a document that has been written over, erased and rewritten countless times, where the faint outlines of the original text are still visible beneath the modern script. The presence of dozens of these streams weaving through the halo and the disk suggests that the galaxy is a much more transparent and orderly place than the visible chaos would imply. Or perhaps it suggests that the forces keeping these threads intact are more mysterious than we currently understand. The stellar streams serve as the ultimate probes of the invisible. Because they are so long and so sensitive to gravitational influence, they act as a cosmic tripwire. If a stream is smooth and continuous, it tells us that the space it occupies is relatively empty. But if a stream is kinked, fanned out, or broken, it reveals the presence of a hidden intruder. Scientists have observed gaps in these ribbons of light that cannot be explained by any visible object. These punches in the silk threads are the fingerprints of dark matter, sub-halos, clumps of invisible mass that have plummeted through the stream, scattering stars in their wake like a bowling ball hitting pins. In this way, the ghosts of the past are helping us map the ghosts of the present. The streams are the only tools we have to see the dark matter structures that are too small to catch light but heavy enough to leave a scar. This realization deepens the sense of the Milky Way as a non-equilibrium system. We see a galaxy that is perpetually becoming, a structure that is constantly being fed by the arrival of new material. The streams are the conveyor belts of galactic growth, the visible evidence of the Milky Way's ongoing metabolism. They show us that the process of building a galaxy is never truly finished. Even now, as we speak, clusters are being torn apart and turned into new streams, adding their stars to the grand overlapping web. The motion of these ribbons tells us that the galaxy has a long memory. The kinetic energy of a collision that happened before the birth of the Sun is still preserved in the flight of these stars. The imagery of silk threads in a storm is more than just a metaphor. It is a description of a fundamental tension in galactic physics. It highlights the struggle between the order of orbital mechanics and the chaos of a many-body system. The fact that these streams exist at all is a testament to the sheer scale of the vacuum. Space is so vast that even within the crowded disk of a galaxy, stars can move for billions of years without ever colliding, preserving their original trajectories like ancient travellers on a long-forgotten road. We are only now learning to read these roads, to follow the threads back to their source, and to reconstruct the original map of the local universe. As we disentangle this web, we find that the Milky Way is a place of incredible structural complexity. We are not just looking at a disk of stars. We are looking at a three-dimensional intersection of countless different orbits, each one representing a different origin and a different fate. The broken physics of our home is revealed in the way these structures coexist without merging, the way they maintain their identity in the face of overwhelming gravitational pressure. The stellar streams are the quietest witnesses to the galaxy's violent past, but they speak with a clarity that the bright, noisy stars of the disk cannot match. They remind us that the story of our home is not a single narrative, but a collection of billions of individual journeys, all woven together into a single shimmering and defiant whole. But even this complex and resilient structure is not permanent. The threads that have survived for eons are now being pulled toward a final, inevitable confrontation that will rewrite the laws of galactic evolution once again. Across the silent, light-years-wide gulf of the intergalactic void, a looming presence is growing. The Andromeda Galaxy, a sister spiral of even greater mass and scale than our own, is currently falling toward the Milky Way at a speed of 250,000 miles per hour. This is not a random drift, but a relentless gravitational collapse that has been set in motion since the dawn of the local group. The two great empires of our corner of the universe are locked in a fatal embrace, their dark matter halos already beginning to touch and intermingle in the deep dark. This impending merger, scheduled by the laws of gravity to begin in roughly 4 billion years, will not be a simple joining of two systems, but a chaotic, incandescent transformation that will fundamentally rewrite the laws of galactic evolution. The approach of Andromeda will first be felt as a subtle tidal pressure, a stretching of the outer reaches of the Milky Way that will pull the stellar streams and the warped edges of the disk into new, erratic shapes. As the two galaxies close the final gap, the sky of any world still orbiting a sun will be dominated by a second, glowing river of light that rivals the Milky Way in brilliance. This is the beginning of the starburst phase, a period of frantic creation triggered by the compression of gas. As the vast clouds of hydrogen within both galaxies collide and overlap, they will not pass through one another like ghosts. Instead, they will smash together, generating shockwaves that ripple through the interstellar medium. These shocks will cause the gas to collapse in thousands of locations simultaneously, sparking the birth of millions of new stars in a display of cosmic pyrotechnics that will illuminate the entire local group. Despite the scale of the collision, the stars themselves will almost never touch. The distances between individual suns are so vast, millions of times their own diameters, that they will pass by one another like ships in a foggy night. However, their orbits will be shattered. The elegant spiral arms that have defined the Milky Way for 10 billion years will be torn apart by the competing gravitational pulls. Long, thin ribbons of stars, known as tidal tails, will be flung out into the intergalactic void, stretching for hundreds of thousands of light-years like glowing tentacles. The orderly, circular motion of the galactic disk will dissolve into a chaotic three-dimensional swarm. The Sun, along with its retinue of planets, may be tossed into the far reaches of the new structure, or perhaps even ejected entirely into the lonely dark between the galaxies. Out of this wreckage, a new and unrecognizable entity will emerge, Milky. This will not be a spiral galaxy, but a giant elliptical galaxy, a vast featureless ball of aging stars and depleted gas. The intricate clockwork of the Milky Way will be replaced by a more random pressurized system, where stars move in every possible direction, held together by a collective gravity that has finally found a brutal kind of peace. The birth of Milky marks the end of the era of star formation in our neighbourhood. The gas that once fueled the birth of new suns will have been either consumed in the initial starburst or blown away by the intense radiation of the merger. The new galaxy will be a place of quiet, slow-motion decay, a retirement home for the trillions of stars that survived the collision. At the heart of this new structure, a final and lethal drama will unfold. The two supermassive black holes, Sagittarius, a star from our own galaxy, and the even more massive Titan at the centre of Andromeda, will begin a slow, spiralling descent toward one another. Driven by the friction of surrounding stars and gas, they will sink into the core of Milky, orbiting each other in a dance that grows tighter and faster over millions of years. This is the ultimate expression of the crime scene physics that defines our home. As they approach the final moment of union, they will radiate gravitational waves of such immense power that they will literally shake the fabric of space-time across the entire galaxy. When they finally merge, the resulting explosion of energy will be invisible to the eye but will signal the birth of a singular, monstrous void that will dominate the centre of the new world. This merger is the inevitable conclusion of the competitive history we have traced through the scars of the Milky Way. The cannibalism of the past was merely a rehearsal for this final act. The physics of galactic evolution dictates that all structures within a local group must eventually coalesce, trading their individual identities for the stability of a single, massive hole. The broken nature of our current galaxy, its warps, its vibrations, and its non-equilibrium state, is a precursor to this total reorganization. We are watching the slow-motion collapse of an old order and the violent birth of a new one. The transition to Milky Way will leave behind no memory of the two spirals that once existed. The stellar streams will be mixed into the general population, the Fermi bubbles will have long since evaporated, and the dark heart of the Milky Way will have been swallowed by its larger twin. The universe will have moved one step closer to its final, most stable state. But even this new, massive galaxy is not the end of the story. The same physics that drives these structures together will eventually become the force that pulls the rest of the universe away. As we look toward the final silence, we realize that the merger of the Milky Way and Andromeda is a brief flare of activity in a cosmos that is slowly, inexorably cooling. The grand, chaotic transformation of the merger is the last great gasp of a local universe that is running out of time. The expansion of the universe is a silent and relentless thief, a force that began as a whisper in the earliest moments of time and grows into a scream that will eventually drown out the light of every star. Beyond the chaotic birth of Milky Way, the very fabric of space-time continues to stretch, driven by the repulsive pressure of dark energy. This expansion acts as a cosmic horizon, pushing distant galaxies away from our local neighborhood at speeds that eventually exceed the velocity of light. One by one, the other islands of the universe vanish from view, leaving Milky Way as a solitary flickering lantern in an infinite and growing sea of nothingness. The grand interconnected web of the cosmos is being systematically dismantled, and the galaxy is entering its final, most lonely epoch. In this distant future, the physics that once built the world through the collapse of gas and the ignition of fusion becomes the mechanism of its own destruction. The galaxy has run out of the raw materials necessary to forge new suns. The great nebulae, once the nurseries of stellar life, are now cold and depleted, their hydrogen spent or locked away in the husks of dead stars. The Milky Way's successor is a graveyard of red dwarfs, white dwarfs, and neutron stars, all slowly cooling toward the temperature of the void. The vibrant, chaotic energy of the early universe is being replaced by the iron grip of entropy. This is the beginning of the heat death, a state where all usable energy has been exhausted, and the temperature of the cosmos approaches absolute zero. The last star in the galaxy will likely be a tiny red dwarf, a humble orb of fusion that has eked out its existence for trillions of years. This star, perhaps only a fraction of the mass of our Sun, is the final witness to the legacy of the Milky Way. Its light is a dim, crimson ember in a sky that has turned completely black. Around it, the remnants of planets may still orbit, frozen and lifeless, their atmospheres long since turned to snow. When this final star finally exhausts its supply of hydrogen, it will not go out with a violent explosion. Instead, it will simply fade, its internal fires cooling until it becomes a black dwarf, a cold, dense sphere of degenerate matter that emits no light and no heat. With its passing, the era of starlight comes to an end, and a great silence descends over the cosmos. As the stars vanish, the focus of the universe shifts to the dark heart that remains. The supermassive black hole at the center of Milky Way, now a gargantuan void containing the mass of billions of suns, is the only significant structure left in the darkness. But even this titan is not immortal. According to the laws of quantum mechanics, the vacuum of space is not truly empty, but is filled with virtual particles that constantly blink in and out of existence. Near the event horizon of the black hole, these pairs are torn asunder. One particle falls into the abyss, while the other escapes into the void as a tiny burst of energy. This is Hawking radiation, a process of incredibly slow evaporation that will take a period of time so vast it defies human language, a number of years represented by a 1 followed by 100 zeros. Over these unfathomable eons, the black hole will slowly lose its mass, radiating its substance back into the empty universe one particle at a time. The physics that once allowed this void to anchor a galaxy now dictates its slow and agonizing disappearance. In its final moments, the black hole will grow smaller and hotter, its evaporation accelerating until it vanishes in a final, brilliant flash of gamma rays. This is the last energetic event in the history of the galaxy. Once the black hole is gone, the space where the Milky Way once spiraled will be truly empty, populated only by a thin, cooling gas of photons and neutrinos that will continue to stretch and fade forever. In some models of the ultimate end, the expansion of the universe does not merely isolate the galaxies, but accelerates until it begins to attack the very structures of matter itself. This is the Big Rip, a scenario where the tension in the fabric of space-time becomes so great that it overcomes the fundamental forces of nature. First, the galaxy is torn apart, its stars scattered into the expanding dark. Then, the gravity of individual suns is overwhelmed, and planets are ripped from their orbits. Finally, the force penetrates the microscopic world, tearing molecules apart, then atoms, and finally the very subatomic particles that make up reality. The universe becomes a sea of disconnected points, a realm where no two things can ever interact again. Whether through the slow, cold descent of the heat death or the violent shredding of the Big Rip, the result is the same: the total erasure of the Milky Way's legacy. The structures that we spent centuries mapping, the stars we named, and the history of collisions we reconstructed will all be reduced to a state of perfect, featureless equilibrium. The cosmic crime scene will be scrubbed clean, leaving no evidence that the light ever existed. The physics that built our world, the gravity that drew the gas together, the nuclear force that lit the stars, and the electromagnetism that allowed us to see, will have completed its work, leaving behind a void that no longer remembers the scream of light or the dance of the suns. The Great Silence is the final chapter of the galactic narrative. It is a state of maximum entropy where time itself ceases to have any meaningful direction, because nothing ever happens and nothing ever will. The trillions of years of stellar evolution, the grand mergers of galaxies, and the brief, flickering moment of human observation are all swallowed by an infinite and unchanging dark. We are the inhabitants of a brief and beautiful anomaly, a period of history where the universe was young and energetic enough to support the complexity of a galaxy. As we look into the night sky, we are seeing the beginning of the end, a masterpiece of light that is already in the process of being dismantled by the very laws that gave it life. This eventual silence is not a failure of the universe, but the ultimate fulfillment of its physical destiny, a transition from the noise of creation to the perfect peace of the void. The observer remains upon the jagged precipice, a small and fragile consciousness perched at the lip of the intergalactic nothingness. From this distance, the silver river of the Milky Way still appears as a vision of celestial harmony, a silent and perfect clockwork of 200 billion suns, but the eyes that look upon it now see through the illusion of order. The watcher understands that the very brokenness of the galaxy, the warped disk, the invisible scaffolding of dark matter, the howling abyss at the centre, and the scars of ancient cannibalism, is the fundamental reason for their own existence. If the Milky Way were the perfect static machine that the early cartographers envisioned, it would be a sterile and lifeless tomb. A galaxy governed by simple, predictable equilibrium is a galaxy where nothing ever changes, where the gas never collapses into new fire, and where the heavy elements of life are never forged or scattered. The chaos we have uncovered is not a defect in the design, but the engine of creation itself. A perfect clockwork galaxy would have consumed its fuel in a single efficient burst of star formation at the beginning of time, leaving behind a cold and unchanging graveyard. Instead, the Milky Way is a site of perpetual, violent renewal. The turbulence triggered by the collision with Gaia Enceladus and the ongoing shredding of the Sagittarius dwarf are the very forces that compress the vast clouds of hydrogen, sparking the birth of new generations of suns. The broken physics of the rotation paradox, the invisible iron grip of dark matter, ensured that these stars remained bound together long enough for planets to form and for life to take hold. Without the spectral scaffolding that mocks our equations, the stars would have drifted apart into the lonely dark, and the chemical complexity of a world like ours would never have been possible. Every atom in the body of the observer, from the calcium in their bones to the iron in their blood, is a relic of this galactic crime scene. These elements were forged in the hearts of massive stars that lived fast and died in spectacular explosions, their guts cast into the void by the very instability we once feared. We are the beneficiaries of a billion-year metabolism that breathes through the Fermi bubbles and pulses with the energy of the central black hole. The dragon in the basement, with its relativistic jets and its crushing gravity, acts as a cosmic regulator, preventing the galaxy from becoming too dense or too stagnant. The dragon's breath and the tidal scars are the fingerprints of a system that is alive with the struggle between gravity and light. The realization dawns that our struggle to understand the broken physics of our home is actually the universe attempting to understand itself. We are not outside observers looking in. We are a part of the tapestry, a collection of atoms that have spent 13.8 billion years wandering through the dark. We began as primordial hydrogen in the wake of the beginning, were pulled into the first stars by the tug of dark matter, were crushed in the hearts of supernovae, and were eventually swept up into the swirling disk of a scarred and beautiful spiral. After eons of silent drifting, these atoms have come together for a brief, flickering moment to form a brain, an eye, and a heart. We have woken up just long enough to look at the stars and wonder why they are moving so fast. This ignorance is not a failure of our science, but a testament to the sheer, magnificent scale of the mystery we are privileged to inhabit. The fact that the Milky Way defies our equations is a gift. It means the universe is deeper, stranger, and more complex than our small minds can yet grasp. We live in a brief window of cosmic time where the light of distant galaxies can still reach us, where the stars are still burning, and where the dark heart of the galaxy is still visible through the dance of its neighbours. We are the witnesses to a grand, multi-billion-year performance that is moving toward an inevitable and silent conclusion. The observer on the cliff feels the weight of this history, the pressure of the 90% of the galaxy that remains invisible, and the heat of the eruptions that carve the gamma-ray lungs of the Milky Way. There is a profound privilege in being the ones who get to ask the questions, the ones who get to map the scars and name the ghosts. We are a brief flare of consciousness in a universe that is mostly dark and mostly silent. Our lives are a fraction of a second in the life of a star, yet we've reached out and measured the mass of a black hole 4 million times heavier than our sun. We have decoded the light of stars that died before our planet was born. As the watcher turns away from the intergalactic void and looks once more at the silver river of light, the fear of the chaos is replaced by a sense of awe. The crime scene is actually a sanctuary. The broken physics are the rules of a game that allows for complexity, for beauty, and for life. The Milky Way is a magnificent, scarred, and defiant masterpiece, and we are its most improbable creation. We are the atoms that woke up to tell the story of the dark, the light, and the gravity that holds them both. In the face of the great silence that awaits at the end of time, our brief moment of wondering is the greatest triumph of the cosmos. The mystery is not something to be solved and discarded, but something to be inhabited with gratitude. We are the eyes of the universe, looking back at the silver light, forever humbled by the speed of the stars and the depth of the dark.